Alright, today I'm going to go over the 1.5 homework. I'm going to go through part 1 rather quickly because I did it all in class, so that's going to go pretty quick, and then I'll slow down a little bit for part 2. This is pretty much the board from yesterday, and it's pretty much all the hints you're going to need. So the biggest idea is going to be these perfect squares. Remember, these are perfect. These are perfect numbers, all these right here on the far left. So these are going to tell me the numbers I'm going to look to divide for out of my radical. Remember, the product property right here tells me that I can split up a radical, so that lets me take out the perfect square. What we're going to use a lot for is when we combine radicals. Remember, I call the radical a jail. So if both numbers are inside the jail, you can multiply them together and make them into one jail. I use the quotient property a lot. When I have a fraction inside the radical, I'll take the radical at the top and the radical at the bottom. Now, remember we talked about 2 rules that need to be satisfied in order for your problem to be done. The first thing that needs to be satisfied for your problem to be done is you can't have any perfect square factors that divide into the radical. That's what this list is for right here. The other part is you can't have a radical in the bottom. That's when you're going to use conjugates. So if you have a radical in the bottom, you're going to end up using conjugates. There's an easy conjugate, which is no plus or minus sign with a number, and you just make the radical exactly the same. Or there's a hard conjugate, where you have a plus a radical or some number minus a radical. And then the conjugate is just the same numbers inside the radical and outside the radical, but you put the opposite sign in the middle. And if you don't want to FOIL it, there is a shortcut right here. Is the shortcut in order to simplify it. Remember, if you're solving, PEMDAS backwards is how we're going to solve, because, hopefully you remember, this works because there's going to be one variable. So in our problems today, you're going to have one variable, which is why you're allowed to use PEMDAS backwards. All right? Let's get started. All right. In radical 72, what is that called? The number inside the radical is always called the radicand. Number 2, when it says rationalize the denominator, that's just a fancy way to say eliminate the radical from the bottom using conjugates. Alright, that's it for 1 and 2. Alright, so number 4, I have a square root of 192. So I go through my list: 1, 4, 9, 16, 25, 36. And I keep on going, and so forth and so forth. And I find out 192 is not perfect. So I go through my list and I find out 64 goes into 192. So I rewrite this as 64 times 3. 64 is perfect. He gets to leave the jail. Remember, if you got to leave jail, you got to change, or you go right back in jail. So 64 changes. The square root of 64 is 8. 3 is not perfect. He stays in jail forever. Final answer is 8 radical 3. That's it for 4. Alright, number 6, I have the square root of 3 times the square root of 27. I multiply them both together because they're both in jail, so I get the square root of 3 times 27, which is the square root of 81. The square root of 81 is perfect, so it is just 9. That's it for number 6. Done. Now, for number 8, there's a couple ways to do it, but the easiest way I'm going to do it is I'm going to say 5 and 3 are both outside, so I multiply those to get 15. 240 and 10 are both inside, so I multiply those to get 240. The perfect square that goes into 240 is actually going to be 16 and 15, because 16 times 15 is 240. So I rewrite this as 15 square root of 16 times 15. 16 is perfect. He leaves the jail as 4. That 15 right here stays on the inside forever. Final answer is just 60 radical 15, and you're done. Alright, number 10, I have a fraction inside the radical, so the first thing I do is I take the radical to the top, the radical to the bottom. The top is simplified. There are no perfect numbers that go into radical 35, so it just stays the same. The bottom is perfect, so it just turns into 6, and that's your final answer. Alright, number 12, I have 7 over radical 12. Now, if you're not sure what to do, remember the first thing you should do is just look at if it was radical 12 by itself. then you would just break down the radical just the way you would. So I'm gonna not even worry about that radical being the bottom. I'm gonna say what numbers go into 12? Well, 4 is perfect. It goes into 12 as 4 times 3. So this 4 gets to leave jail. So this turns into 7 over 2 radical 3. Now, I am not allowed to have a radical in the bottom. So you're not allowed to leave a radical in the bottom. So I need to multiply. That's why I always make that box. I always make that box just so I know that it has to equal 1. It's a visual cue to me telling myself whatever I create has to equal 1. Now this right here is actually, this is an easy conjugate because there's no plus or minus sign. So I take this radical and I just write that again right here. I put radical 3 there. Now, to make this equal to 1, I put radical 3 on top. Now I'm going to multiply across the top, multiply across the bottom. I get 7 radical 3 all over 2 times 3 and 3 are both in jail. I get radical 9. Remember, radical 9 is 3, so I get 7 radical 3 all over 6. That's my final answer. Alright, 14. I have a fraction inside the radicals. So the first thing I do is I take the radical to the top, radical to the bottom. Now, I'm going to look at 28. Before I try to get rid of the radical on the bottom, I break it down. I say 28 can be written as 4 times 7. 4 is perfect. It gets to leave the radical, so that this fraction turns into the square root of 13 over 2 radical 7. I can't break down the top, but that's okay. So now I'm going to multiply by a conjugate. Remember, I multiply, I put a box there to remind myself that this has to equal 1. Just a visual cue. You don't have to put the box there. I just do it so I remind myself whatever I put in this box has to equal 1. It's an easy conjugate because there's no plus or minus sign between that number and the radical. So I just take radical 7 and I write it once. Now I copy and paste the bottom onto the top because if I don't, this box doesn't equal 1 and I'm changing the value, and you're not allowed to do that. So now I multiply across the top and multiply across the bottom. 13 times 7 is 91. They're both in jail, so they stay in jail. 2 times radical 7 times radical 7. Now the shortcut is if I multiply radical 7 times radical 7, I don't want to do the work. I could just write 7. The radicals will cancel each other out. So this is 2 times 7, which is 14. Done. That's it for 14. Now you do have to make sure there are no perfect sets going to 91, and I already did that. So, but if the off chances that was like 99, there would be a perfect number that could go into it, but it's not. So, all right, I have 1 over 5 plus radical 6. Radical 6 cannot be broken down, so the only rule that's being broken is you're not allowed to have a radical on the bottom. So there's no radical allowed in the bottom. So I have to multiply by a conjugate. That's why I make the box. It's just me reminding myself, hey, whatever's in this box has to equal 1. Now this is a hard conjugate, which means I take 5 plus radical 6, I rewrite it, but I put a minus in the middle. I do the same thing on top. I put 5 minus radical 6. Because if the top and bottom don't match exactly, then it doesn't equal 1. Now I'm going to multiply across the top, which is really easy because 1 times anything is just anything. That's why it's 5 minus radical 6. Now the bottom's a little bit tougher because I have 5 plus radical 6, 5 minus radical 6. Now you have two options. You can FOIL, and you'll get exactly, you can FOIL, so you get 5 times 5 is 25. The outside is, 5 is outside of jail, radical 6 is inside jail, so it's minus 5 radical 6. Don't be the guy who puts radical 30 there, and I'll have to do that. 6 is still in jail, 5 is in jail when I do the inside, so I get plus 5 radical 6. The last two is I have 6 and 6, they're both in jail. There's a minus sign in front of the radical. That's why it's minus radical 36. The middle terms cancel out. This turns into 25 minus the square root of 36 is just 6. So the whole bottom turns into 19. That's just the bottom. So my final answer is 5 minus radical 6 all over 19. And that's it for number 16. Alright, 18. I have 3 plus radical 7 over 2 minus radical 10. So I have to find the conjugate. That's why I multiply. I make the box. Remember, the box has to equal 1. So I'm going to put 2 plus radical 10. And on top, I'm going to put 3 minus radical 7. Now remember, that box has to equal 1. I'm going to multiply across the top. 3 plus radical 7. 3 minus radical 7. All over the bottom, 2 minus radical 10. 2 plus radical 10. Now I'm going to FOIL. I FOIL the top. Now if you don't, I FOIL the top, I get 3 squared, which is 9. Minus 3 radical 7. Plus 3 radical 7. Minus radical 49. I do the bottom. I get 4 plus 2 radical 10 minus 2 radical 10 minus square root of 100. So if you don't know how I got those, I use FOIL on both the top and the bottom. The middles cancel. I get 9 minus 7, which is just going to be 2. 4 minus 10 is negative 6. So I get negative 1/3 as my final answer. And that's it for 18. Now remember, when I talked about in class, I talked about taking the square root of something. You find a perfect square that goes into it. Now I always told you guys in class to start at the bottom. That's important in problems like this. So I start at the bottom of this list and I work my way up. 100 doesn't work, 81 doesn't work, 64 doesn't work, 49 doesn't work, 36 doesn't work, 25 doesn't work, 16 works. So I rewrite this as 16 times 6. 16 comes out as 4. So your final answer should be 4 radical 6. Now here's what the book did. They took 96 and they said, look, 4 goes into 96. And they rewrote it as 4 times 24. 4 is perfect. He comes out as 2 radical 24. And then they stopped. You can do it this way, but you have to make sure that this number right here doesn't have any more perfect square factors. 4 can still go into 24. It's 4 times 6. So they didn't do enough work. So 4 also comes out. So it's 2 times 2 radical 6, which turns into my final answer that I got as 4 radical 6. So you can do what the book does, but you can't stop. You always have to double check and make sure there are no more perfect squares, because this is simple. This is simpler than what you started with, but it's not simplified all the way. It's kind of like saying when we talk about fractions and stuff. All right, 22 is pretty easy. S squared equals 169. There's only one letter, so you're allowed to use PEMDAS backwards. There is no subtraction, no addition, no division, no multiplication. There's an exponent. If you look on the board, how do you get rid of an exponent? It says plus or minus square root. That means you take the square root of both sides. Because you have a letter that's being square rooted, you don't know that it's positive or negative. So in the next step, you should have S, because the little 2 and the check mark cancel each other out. But this step makes plus or minus show up right here. And the square root of 69 is just 13. So your final answer is S equals 13 and S equals negative 13. That's it for 22. Alright, 24 is beginning part 2, so I'm just going to keep on moving through this. I get x squared equals 84. So, once again, I can use PEMDAS backwards because there's only one letter. There's no subtraction, no addition, no division, no multiplication. There's an exponent. That's why I square root both sides. The little 2 and the check mark cancel, but in the immediate next step, because that's a letter that's being square rooted, plus or minus shows up. Now, hopefully this looks familiar. Hopefully the square root of 84 looks like something we've done before, and it has. So how do I get 84? How about 4 and 21? Because 4 is perfect. I don't care about 7 and 12. I don't care about 2 and 42. I care about 4 because it's a perfect factor. 4 is perfect. So my final answer is x equals, plus or minus already happened. That's why it's in front of the plus or minus already there. So now it's 2 radical 21. Because 4 is perfect, came as 2. 21 stayed in jail forever. So your final answer is x equals 2 radical 21 and x equals negative 2 radical 21. Now in the future, that you can stop there and that can be your final answer. Alright, 26. I have 4p squared equals 448. I'm going to do PEMDAS backwards. Remember, there is no subtraction, there's no addition, there's no division, there's multiplication. That's why I divide by 4 before I take the square root. Somebody's going to get in the bad habit of trying to get rid of the square root too early. It's easiest if you divide by 4 first. So I get p squared equals 112. Now I take the square root of both sides. I get p. It's plus or minus because there's a letter that's being square rooted. The square root of 112. Now, if you don't know, 112 is 16 times 7, where 16 is perfect. So p comes out as plus or minus, 16 comes out as 4, 7 stays in jail forever. So your final answer is p equals 4 radical 7, and p equals negative 4 radical 7. Remember, I want you to write your answer out twice because I need you to understand that plus or minus means two different answers. And that's it for 26. Alright, so once again, I have one letter. I'm going to use PEMDAS backwards. Somebody's going to get in the bad habit of not because they're going to see that 25 and think they should square root right away. But you don't. You get rid of subtraction first. That's why the first thing I do is I add 10 to both sides. I get 7r squared equals 35. There's no more subtraction. There's no addition. There's no division. Oh, there's multiplication. That's why I divide by 7 before I take the square root. I get r squared equals 5. Now I'm finally allowed to take the square root of both sides. I get r equals plus or minus radical 5. Don't forget your plus or minus. Remember, it showed up here. So my final answer is r equals radical 5 and r equals negative radical 5. That's it for 28. 30, I have t squared over 20 plus 8 equals 15. So once again, if you're lost, even if you're lost on a quiz, if there's one variable, you put PEMDAS backwards, that's a half point for free. There is subtraction, there's addition, that's why I'm minus 8 from both sides. I get t squared over 20 equals 7. There is no more addition. Oh, look, there's division. So how do I get rid of division? By multiplication. So I multiply by 20 on both sides. I get t squared equals 140. Now I'm finally allowed to take the square root of both sides. So I get t equals plus or minus the square root of 140. Now I'm not done. Somebody's going to forget to break down this radical. 140 is 4 times 35. 4 is perfect, 35 is not. So my final answer is t equals plus or minus, already happened, 2 comes out, radical 35. So I finish my answer as t equals 2 radical 35 and t equals negative 2 radical 35. And that's it for 30. 32, it's just PEMDAS backwards again. Do not get confused because of the parentheses. Right? It's just part of PEMDAS backwards. So I see subtraction, but that subtraction is actually in the parentheses, so I can't get rid of it yet. I also see subtraction outside the parentheses. I can get rid of that subtraction by adding 18 to both sides. So notice, the x minus 4 was not touched, it's still squared, equals 28. There's no addition, there's no division, there's multiplication. That's why I divide both sides by 7. Somebody's going to try and distribute. There is no distribute here. There is no word FOIL there. The only way to get rid of multiplication is by division. So I end up with x minus 4 squared equals 4. Now I square root both sides. Because even though there's subtraction, it's still in the parentheses. I cannot get rid of it. I have to get rid of the exponent first. But remember, that's a letter. So when I write x minus 4, it's equal plus or minus, and the square root of 4 is just 2. Now I'm finally allowed to add 4 to both sides. But remember, x equals 4 plus or minus 2. The plus or minus already happened. That's why the 4 is in front of it. So to get your answer, you get x equals 4 plus 2, which is 6, or x equals 4 minus 2, which is 2. Two answers there. All right? Even if this was a problem like next week, you still have to write this one out because since there is no radical, you do have to actually give me your answer as 6 and 2. All right, and that's it for 32. All right, so first things first is I'm going to try and simplify any radicals if I can. So even though it's a solved problem, which is just PEMDAS backwards, I know that I can rewrite radical 12 as 4 and 3. So this radical 12 can be rewritten as 2 radical 3. Now, this is just like if I erased all the radicals, this would be just something like 2. I would subtract 2 from both sides to get away from the x, so I'm just going to minus 2 radical 3 from both sides. Now, when it was just 12, it didn't work out because they weren't like radicals, but now they are. So I get minus x, radical 2 is less than or equal to radical 3 minus 2 radical 3 is actually just minus radical 3. Now, think of this as a coefficient. That's like radical 2 times x. So I'm going to divide both sides by minus radical 2 minus radical 2. So I get x equals positive radical 3 over radical 2. I'm done, except this is not simplified, so I have to multiply by a conjugate. It's an easy conjugate. Remember, that has to equal 1. So my final answer, and remember, when you divide by a negative, it flips this. So I get x is greater than or equal to radical 6 all over 2. Right. We'll probably go over that one in class in a little bit more detail. Alright, this one's pretty tough. It takes some a little bit of slick math work going on. So the first thing I'm going to do is I'm going to minus x from both sides just because I like to get my x's on the same side. Now they're not like terms because that has an x radical 3 and that's an x. They're not like radicals. So I'm just going to write x radical 3 minus x is greater than 2. Now what I do notice is these have an x in common. So I'm going to pull out that x. I'm going to put radical 3 minus 1 inside there, and it's greater than 2. Now I'm going to divide everything by radical 3 minus 1. And I get x is greater than 2 over radical 3 minus 1. Now I'm going to multiply both the top and the bottom of my answer by the conjugate, radical 3 plus 1 over radical 3 plus 1. So x is greater than, the top turns into 2 times the quantity radical 3 plus 1. The bottom is 3 minus 1, which is just 2. The 2's cancel. 3 minus 1 is 2. Those 2's cancel. So my final answer is x is greater than radical 3 plus 1. Once again, that's a kind of complicated way to solve that, but it worked. All right, in C, once again, I got get x by itself, so I minus 4 from both sides. So I get 2 radical 5 minus 4 equals x over radical 8. Now I have to divide everything by radical 8. That's to make x all by itself. So I get x equals 2 radical 5 minus 4 all over. Now radical 8, if you didn't know, is 4 times 2. So it's 2 radical 2. So to make my life a little bit easier, before I go any further, I'm going to say, look, all 3 of these can be divided by 2. So my final answer right now is x equals radical 5 minus 2 all over radical 2. Now I'm going to multiply everything by the conjugate, radical 2 over radical 2. It's a simple conjugate. So I'm going to distribute that radical 2 to both. So my final answer is radical 10 minus 2 radical 2 all over 2. And that's it for C. Alright, so I'm gonna make some sort of equation. And it's gonna look something like this. X squared equals a number. Where it has two real solutions. Here's a good one. X squared equals 169. Why? Because we already did this one. We had x equals 13 or x equals negative 13. One solution. How about x squared equals 0? The only way this can be true, plus or minus doesn't matter with that, so x is equal to 0. There is no second solution. Now, a no real solution answer is pretty easy. How about x squared equals negative 4? There is no problem squared that gives me a negative number. So that one is not possible. That's no real solution. That's it for 36. Alright, for 38 you had to know that h equals minus 16t squared plus h sub 0. That's just the equation for a dropped object. It's incorporating gravity and stuff, okay? So, a cliff dives off a cliff 40 feet above water. Write an equation that gives the diver's height in feet above the water after t seconds. So, I know he started 40 feet in the air. That's where he starts. That's where he ends. So, the equation is h equals minus 16t squared plus 40. In this problem, h is going to be equal to 0 because that's sea level. So what I'm going to do is I'm just going to solve for t. So I'm going to add 16t to both sides. Now I divide both sides by 16. So I get t squared equals 40 over 16 is the same as 5 halves. And then I square root both sides. So I get t equals plus or minus the square root of 5 halves. Now, I don't need to worry about the negative because this is a real life. You can't have negative time. And I'm actually allowed to throw this to my calculator because we're talking about time, and we don't measure time in radicals. So you could actually use your calculator and give me about 1.6 seconds. And that's it for 38. All right, so they give you this equation, h equals 0.019 s squared. That's for the height, where h is the height of the wave, where s is the speed of the wind, and they measure wind in knots. So they want to compare how much is the width difference in wind for 5-foot waves. So really, to figure that out, I have to put 5 in for h, and I equal 0.019 s squared. Now I have to divide both sides by 0.5. I have to divide both sides by 0.019. And then I square root both sides. I get my speed for a 5-foot wave. Is about 16 knots. Now I do the same thing, but this time h is equal to 20. So now this is a 20-foot wave. So I get 20 equals 0.019 s squared. I divide both speeds by 0.019. I get 20 over 0.019 equals s squared. I square root both sides. So my speed equals to that 20 over 0.019 in my calculator. And this time I got 32. So the speed doubles for the wind. The wind has to double in order for the waves to go from 5 feet to 20 feet. So it's a little bit tougher, but it's not too bad. 42 is accuracy. And that completes this assignment.